Hey everybody, this is Mr. Longo, and in this video we are going to cover some parts of a graph that you are probably familiar with, such as X-Intercepts, Y-Intercepts, and then also whether or not certain points are on a graph, stuff like that. So to do that, it really just requires a little bit of algebra. Just a couple things to remember. X-intercept is when the graph crosses the x-axis, meaning at all time your y value will be 0. A y-intercept is where the graph crosses the y-axis, meaning at all times x will be equal to 0 for those, okay? So the rest of this is just a little bit of algebra. So for the next 5 questions, what we are going to do is find the x-intercept, y-intercept, determine if points are on a graph algebraically, okay? So to do that, to find your x-intercept, remember your x-intercept is some number, comma, 0. So all we're going to do is plug 0 into y and solve for x. So 0 is equal to, and if it helps for you to use parentheses, do it. X minus 3 over x minus 1. How do we solve for x? Well, get rid of your denominator by multiplying both sides by x minus 1. Those will cancel, and x minus 1 times 0 is, of course, 0. So 0 is equal to x minus 3. So x is equal to 3. Your x-intercept is 3, 0. To work with your y-intercept, remember that is when x is 0, some other number. This is the easy one to find, because y is equal to, and now all you have to do is plug 0 into both x's. So you have 0 minus 3 over 0 minus 1. Negative 3 over a negative 1 is a positive 3. So y is equal to 3, so your y-intercept is 0, 3. When you are asked to determine if a certain coordinate is on the graph, you plug x and y into the given function and determine if it is true or false. So we're just going to plug 2 into y, and that's equal to, now we're just going to plug 6 into x. So we have 6 minus 3 over 6 minus 1. So 2, is that equal to? 6 minus 3 is 3 over 6 minus 1 is 5. No, that is not the case. That's a false statement. So no, 6, 2 is not on the graph. Okay, so those are how you do some of those types of questions. So what if I'm telling you x is equal to 5? What if I'm telling you y is equal to a negative 1 and I want you to find the other part of that coordinate? All you have to do is something very similar to what we did above with our x-intercept and y-intercept. Instead of plugging in 0, you're plugging in a number. Why don't you pause the video and try those two and see if you can get it. Give it a shot. So if x is equal to 5 and you're looking for y, so that's y is equal to, and you're just going to have 5 minus 3 over 5 minus 1. That's going to give you 2 over 4, so of course that means y is equal to 1/2. When you're working the other way around and you're given y, that is negative 1 is equal to your x minus 3 over x minus 1. Just like we did in an earlier example, if it helps you to write those in parentheses, go for it so you remember to distribute. We're going to multiply both sides by the denominator to get it to go away. Distribute negative 1 to both of those. That gives you negative x plus 1 is equal to x minus 3. And of course, we're just going to solve this algebraically, and we get 4 is equal to 2x after we move over our 3 and our negative x, giving us x is equal to 2. Okay, that's what you should have got for that example. The last problem here is evaluating or thinking about it on a graph, okay? So whenever it says something along the lines of h of negative 2, whenever it's inside the parentheses, that is telling you that the x value is negative 2, 0, and 2 for this situation. So if x is equal to negative 2, you just go to negative 2, And this looks like a negative 2 down here. So you're just looking at the point. This is negative 2 comma negative 2. So x is negative 2, y is negative 2. But you don't have to list out all of your coordinates. When x is 0, we have 0 comma 3. So h of 0 is equal to 3. What's h of 2? H of 2, we're just going to go to where the graph is 2 for x. We have 2 comma 0. The next example is when we're looking for which x values give us the y value. So this says y is negative 4. So it sometimes is helpful to draw a horizontal line at negative 4. And we see that x is equal to 4 is the only x value that gives you negative 4. But if h of x is equal to 0, that is a little bit different. So if h of x is equal to 0, that's our x-axis, we have 3 different coordinates where y is 0. We have a negative 3, negative 1, and a positive 2. Okay? So that's how you evaluate. Domain and range is something that you are already familiar with after the domain and range video. Our leftmost point is a negative 3, and our rightmost point is 4. And the range is from the bottom to the top, so from negative 4 to a positive 3. But this one, when is h of x greater than 0? That's only when it is above the x-axis. So when is this graph above the x-axis? It is from negative 1 to 2, but not including negative 1 and 2. So it would be from negative 1 to 2 using our interval notation. You do not use brackets because at negative 1 and 2 you are equal to 0, not above 0. Okay? So that's it for this video on parts of graphs and a function. That's it. This is Longo and I'm out. See you, bye.